Yes, guys, this is just for your consent that I have started recording of the session. And today we are going to discuss about the complete end-to-end application setup and the flow of traffic. How does it work? Like what is the particular entry point for our traffic? What sort of components are usually used in order to serve the traffic, to secure it, right? That way. So guys, if I ask you a particular question, can you explain three-tier architecture? What all components have you used in order to set up an application? Is there anyone who can answer this question? Anyone?
Yes, sir. Can I try?
Yes, sure.
We can use Route 53 load balancer.
Route 53 as load balancer or like what?
EC2 for web server and application server and DV.
Okay.
And
Guys,
for
please mute yourself if you're not speaking. That will help. Okay. Route 53, then?
load balancer.
Okay.
EC2 for server.
Okay.
And for network infrastructure, we can use VPC.
So until and unless you create VPC, you shall not be able to create load balancer, EC2, and maybe your auto skill group as well.
Yeah.
Right?
Yes. So first we need to create that network infrastructure. First VPC, then only we can create EC2. Right?
You're right. Okay, let me explain. So guys, first of all, we will talk about DNS component. So for DNS, we can use Route 53. And before this, so let us purchase a domain from GoDaddy. So GoDaddy.com is going to work for us as a domain registrar, where from we have purchased a domain. Now we have hosted our domain onto Route 53. Right, guys? And what does it mean like we have hosted? So we have changed the DNS record set from GoDaddy to AWS Route 53. So this is not a fancy name, guys. This is a really meaningful name. So 53 is a port number of DNS, right? 53 is a port number of DNS. And guys, one more thing we need to keep in mind, 53 port number works on UDP by default. But yes, if you want, we can definitely enable this on TCP as well. But by default, DNS works on UDP protocol. We will have a detailed understanding of TCP and UDP as well later on. But right now, we need to keep in mind, DNS works on UDP protocol, and route means this not only works as a DNS, this also works as a global load balancer. This also works as a global load balancer, right? So that is why it is known as route, because it works as a load balancer, and 53 is the port number of DNS. So this is actually not a fancy name, which is known as Route 53. This is really meaningful, right? Okay, so first of all, we are going to use this Route 53 for DNS purpose only. Now we have hosted this. Now guys, we have our VPC. This is a VPC section. Let me give it a name like VPC. Guys, what does VPC mean? VPC stands for, what is the meaning of VPC?
Virtual private cloud.
Great. So this
it's a virtual network.
Exactly. Yeah, great. You are right. Absolutely right. So this is known as virtual private cloud. This is an isolated network segment in AWS infrastructure, which can be accessible by you only. No other customer of AWS shall be able to reach out to you without your permission. If you want to have a collaboration with them, then it is okay. Otherwise, no one will be able to access your infrastructure without your permission. That is known as VPC, Virtual Private Cloud. Okay. So now we have hosted our website on DNS. Let us call it www.servergyan.com. Right? This is our website, servergyan.com. Now, where we are going to land the traffic, which is coming from internet directly. So guys, yes, we are going to have a sort of load ELB here. We are going to have ELB, Elastic Load Balancer. So guys, when we are going to talk about ELB, so there are two major type of load balancers which we have. So the very first one here is known as
Application.
yes, application
The
ELB,
second one is
and
network.
second one is going to be
Network.
network ELB. Okay. Yes, network ELB. So guys, we need to understand that what are the use case of application load balancer and what are the use case of network load balancer. So as the name suggests, application, right now, whenever we need to forward or we need to manage traffic for HTTP or HTTPS protocol, keep this thing in mind. Whenever we need to route traffic or we need to manage traffic for HTTP or HTTPS protocol, then we are supposed to use application elastic load balancer. Or when we want to use any other type of load balancer, including HTTP, then we can use network load balancer. Right, guys? So what are the advantages of application load balancer? Let me tell you. First of all, it will provide you host-based routing. It will provide you path-based routing. I'll be explaining the use case of this load balancer in a while. So many people say like real-time project. So guys, the things which I'm going to tell you right away, these are part of real-time project only. A person who has worked in a real time should be knowing these sort of things. So the second thing is known as path-based routing. Third thing, source IP address-based routing. Next, request method-based routing. Next, application request header. And like a couple of others are there, like one or two or others are also there. So these are not really that much useful. Otherwise, these are the like major one: host-based routing, path-based routing, method-based routing. Like method could be get, put, trace, delete, option. That sort of request method could be here. So source IP based, like if request is coming from any individual IP address, then what to do? So application load balancer is really going to work here in this case, right? Because we can do host-based routing as well as we can do path-based routing. So these sort of things we are going to like see here. Now, what type of load balancer here we are going to use, guys? This is going to be application load balancer. Are we clear with this? And why is that so? Because guys, we are going to use this particular load balancer to serve web traffic, like traffic which is related to application, or you can call that HTTP or HTTPS, right, guys? So that is why it is required to use application load balancer. And furthermore, there are two schemes. The very first scheme here is the application load balancer could be either internet facing or internal. This thing is also very important. We are going to use internet facing load balancer. We are going to use internet facing load balancer because as I just told you, there are two: either it could be internet facing load balancer or it could be internal. Now, what does that mean, internal? So for example, you have a VPC. In that particular VPC, you have multiple instances which are created inside that. if you want that the particular domain name which you have created that should be accessible from within that VPC or maybe from multiple VPCs. So in that case, what you can do here is you can create internal load balancer. So domain name will be created that will be accessed, but that would be accessible, but within your VPC only. If you try to hit that domain from internet, you shall not be able to do so. Are we clear with this, guys? Any questions so far?
No, sir. Thank you.
Okay, great. So now we are going to like connect this load balancer, this DNS to this load balancer. Right, guys? So this is our Elastic load balancer. Now, what type of this load balancer is?
Application load balancer.
App ELB. This is going to be application load balancer. So let us complete all the components which are related to this. So first of all, this will be application load balancer, and 2 ports are going to be opened on this particular load balancer. And which are the 2 ports which we are going to open? Port number 80 and 443. These 2 ports will be opened on this load balancer whenever someone is trying to access our website from internet. So request on this load balancer will be accepted either on port 80 or port number 443. One more thing, guys, we need to keep in mind, as soon as we enable port number 443, so one SSL certificate will also be associated with this load balancer. Until and unless we have this certificate, could be CA signed, this could be your self-signed certificate, but yes, CA signed certificate is always preferred, because whenever you are terminating your SSL connection, which is coming from internet, and you do not have a CA signed certificate, then that certificate is actually not authorized by all the browsers. You will keep on adding a like error message on client side that the certificate which you are using is not secure. Are we clear with that?
Can you repeat it once?
Yeah.
This SSL part, can you repeat it?
Sure, why not? So there are 2 types of SSL certificate. Either it could be your self-signed certificate that you created your certificate yourself. You executed OpenSSL command. I hope most of you must be aware of it. You created your, first of all, CSR, like certificate sign request. Then after you created one key that is known as private key. And from the combination of CSR and key, you can generate your self-signed SSL certificate. That certificate will be secured without any problem. No one can raise any question on that. But thing here is, if you want that particular certificate should be implemented on any of the web server that should be serving your secure traffic over internet, then in that case, all the browsers are not going to accept that. You will get an error that SSL certificate which you are using is not trusted. In order to get that certificate trusted, we need to get that certificate signed from a CA. CA means certificate authority. If you would like to go in detail of that, we can click on this particular lock icon on any of the website wherever you are working. Just go here in order to identify, in order to verify that. Go here, like you can check connection is secure. Hit here, it will show you certificate is valid. Click on this. Just check this particular diagrams.net. This is domain name issued by Cloudflare. So this is the like certificate issuer. If you want to go in more detail, you can check that particular. If you want to see more details about this certificate, like when it was created, where from it was created, when it was issued, and till when it will be like validated, this will be valid. So every sort of information you can figure out from this particular certificate. In that case, there will be no route. Like this particular information will not be available in case of self-signed certificate. Right, guys?
Yes, sir.
Okay. So first of all, we need to have port 80 and port number 443 opened on load balancer. Some other port numbers can also be opened, known as listener. Okay, someone is asking like how many SSL certificate can add at a time. So like there is no restriction, you can add many as you want. But obviously, like the number of certificates should not be more than 20 on a load balancer, because if you are going to apply rules, because your load balancer has a capacity of 200 rules can be implemented on any listener at a time. So like more than 20 SSL certificates are not recommended to be associated with the load balancer. Technically, you can attach more, but it is of no use, because whenever you are going to do customization on your load balancer, so at that moment, even application load balancer has some restrictions on the top of it. Right, guys? So I hope that we are clear. Like we have purchased domain from GoDaddy, we have hosted it on Route 53, and we have pointed that particular to a elastic load balancer, that is application load balancer, right? Now, guys, we have another component here, which is known as target group. Now, guys, what is target group? So target group is a logical group of EC2 machines which are responsible to serve the same type of traffic, same type of request, right? I'm going to create these target groups here. Let us say I'm going to create 3 target groups. And why is that so? Because guys, right now we are going to talk about microservice architecture. One more thing, whenever we will complete our monolith. Okay, let's talk about monolithic first. So guys, we have a target group and we are running here web servers, right? So web servers are created here. Now, how will you ensure? Let us say sometimes we have 500 requests coming in, or sometimes we may have maybe 10,000 requests coming in. So guys, how will you ensure that all the servers and all the requests which are coming in, they should be intact? Like this request should serve in a well manner. There should not be like crunch of resources. So guys, there is one other component which is going to be added here, and that is going to be auto scaling group. So now guys, what we are going to do, we are going to associate one auto scaling group with this target group, right? We are going to attach one auto scaling group with this target group. What would this particular auto scaling group do? So for example, there is one EC2 machine. There is one EC2 machine. If this instance goes down, for example, this is one EC2 machine. If this machine goes down, right? So all the guys who are aware of AWS, so they must be knowing about one other component which is known as AMI. How many of you?
Amazon machine.
Yes.
Amazon machine image.
Yes, you are right. So there is one component known as AMI, Amazon machine image. So the particular server which is working in production environment, we will create one image of that server, right? And we will assign that image to this auto scaling group, that if number of instances are unstable within this target group, and if we need to add new resource, or if we need to add new server into this target group, use this AMI and provision the same server with same set of configuration, with same set of hardware, with same set of rule, and that should automatically be ready to accept traffic from this load balancer. We will see this particular thing happening in real environment, maybe after a couple of sessions, because first we need to understand like how does it work and why we are doing this particular thing. So first of all, I'm trying to explain you guys that how does actual infrastructure look like, right? Okay. Now guys, there are two things. First of all, we have within auto scaling group, I'm telling you guys, there are two main components you are going to see. First of all, launch configuration. Second thing here is launch template. Yes, there are two components, guys, either launch configuration or launch template. We need to understand that. What is the difference here? So guys, sometimes what happens, there is a restriction that we can add only one type of EC2 machines within a target group. But if we want to have a flexible environment, like not only one set of servers I would like to run within one target group, but I want to have a variation in that. So launch template is the option where you can define multiple type of EC2 machine within one target group. So if you want, why I'm telling you this particular thing, if you want, if you have time, you can explore this particular thing going forward, right guys? But for now, that is good enough for us, that if we understand like how does auto scaling group work, what is AMI, why do we use auto scaling group in order to with a particular target group, because we want to ensure, we want to have some sort of policies here, and like what type of rules we have implemented. So we are going to discuss that in coming sessions. In a nutshell, like based on load average, based on response time from individual target group, right? Based on latency, based on like connection per group, based on number of connection per host, these sort of rules are there which we can use in order to set some auto scaling group policies. For example, if load average on each nodes or each instance which are running in this particular target group is higher or is like more than 50%, in that case we can add more resources. Same thing, because auto scaling group does not mean that it is only going to increase the number of servers. For example, like these are non-peak hours and we know like traffic is very, very low in the morning time. So why to pay additional things? Why to pay for additional resources? AWS auto scaling group can reduce the number of EC2 machines from your target group if traffic is low. That particular threshold we need to identify and we need to define that within auto scaling group. Right, guys? So number of instances are managed by auto scaling group. One AMI has to provide to that particular auto scaling group in order to create new instances like that way. Moreover, guys, one more very important question here is, so we are accepting traffic from internet on port 80 and 443, right guys? But it is not also mandatory that our web server should also be running on the same port as our load balancer is accepting traffic on. We can accept traffic on port 80 and 443 and we can forward traffic here on port number, let us say 1, 2, 3, 4, any port number. These port numbers are not mandatory to be same. These can be different. Are we clear so far, guys?
Yes, sir.
Okay, so let us say we are working like on a secure channel.
Then one more question is there. Rather than load balancing, that a load balancer does serve any services in infrastructure. Rather than load balancing, load balancer serve any services in infra, like
no,
a security or.
This is just a load balancer mechanism, nothing else.
Okay, thank you, sir.
Okay. When we are talking about load balancer, so one more thing, this is very, very important, guys. I would like to bring that into your notice. There are a couple of different algorithms for balancing the load, and these are okay. Yes. So guys, a person can ask you during interview, okay, what algorithm you are using to distribute your load among multiple instances. So guys, we need to understand this as well. What are the type of algorithm do we have? What are the different mechanisms do we have on AWS platform to distribute load?
Round robin.
Great. Round robin. Round robin means if there are 4 requests going to come, first request will be served from here, second here, third here, and fourth one here. That is known as round robin. Irrespective of, for example, this machine has 16 CPU and 32 GB of RAM. This machine has 8 CPU and 16 GB of RAM. This machine has 8 CPU and 32 GB of RAM. And this machine has 8 CPU and 8 GB of RAM. Irrespective of hardware configuration, round robin will forward the request equally onto all the instances. Okay, what is next?
Weighted.
Weighted. Okay, what does that mean?
It's like version. There is a 2 different version. Traffic will
Priority, sir. Priority.
Weight,
Based on
weighted means
priority.
assigning weight to the
so that it will be routed according to the weight which is assigned.
Now, what is this weight and what is the use case? Let's talk some practical. Just feel you are in an interview. You are telling it is according to weight. I'm asking, what is this weight?
Hello.
We can distribute the traffic according to the weight we given.
What is use case of it? Why we are trying to distribute load?
So it's related to the application load.
Because the
The-
server might have different configuration and capacity.
Okay, so in that case, I would answer this question in such a way that I do not have bifurcation in my resources. I want to have static resources for all the target groups. All the resources which are running in my accounts. So these have specific resources. Let us say 10 CPU and 20 GB of RAM. Now, your answer is null and void here. Because I can create scenarios, right? Any other one?
You can define both hardware size and software version.
I think this weight-based policy is based upon the application traffic which is coming. Like, say for example, if you're running a campaign on a particular day or so, we can have in different target groups and make this weight policy enabled to route the traffic. Is it so? That is what I.
Not exactly. Any other one?
If you want to ensure that the specific resource receive only a certain amount of traffic, and this traffic is, I mean, that we can set our traffic across these servers based on maybe their capacity, I mean the size, the geographical location, or the speed.
Not exactly. Okay, let me explain. So guys, basically, when we talk about real-time use cases or real-time project, these are the examples of that real-time project. That if we are using any strategy, then why we are using it? Right, guys? So let us say we have an application running here and the application version is, let us say, V 1.2.3, right? There is a new version released for this application, and that version here is V-1.2.4, right? Now we are not very sure, we are not pretty sure about it, that how is the behavior going to be with latest code. I have created like same set of servers are there, but code is different, right? So what, just a moment, guys.
Hey,
Yes, guys. So let us say I want that only 10% or maybe 5% users, only 5% users should be redirected to new version of applications. Now, what is the use case of this, guys? So use case here is, I just want to understand that whether users are staying on this new application version for longer time, are they like quitting before before usual time, or like what? So rather than impacting my entire application stack, I would like to do sort of canary releases here. So I have done deployment. Maybe like over here, I was having like, let us say 20 servers, but within this target group, I have only 2 servers. Over here, we have 20, over here, we have only 2, right? Only 5% users are redirected to this particular application target group. Are we clear with that?
Yes.
In order to understand the behavior of this newly released code, we would like to have two different target groups. One is working with like previous version of code, and one is working with latest version of code. And that is why we go with weighted mechanism. We will create two target groups serving same set of content with latest code, and 5% traffic, like we can define it like 95 and 5, which means 5% traffic will be forwarded here and 95% traffic will keep on serving from this particular instance only. Moreover, what we can do, like we can modify the scaling policy here. Like earlier we were having like 20 instances here. So we can reduce it to 18 because 2 instances are already created here that way. So do not go on this particular like these two icons. Just go on the particular like numbers which we are discussing here, right? Okay, what is third one? Least connection. Now guys, what does that mean, least connection? So it means, let us say we have only one target group, and right now let us say let us increase couple of more instances here. Like this, we have couple of instances running here. Now all the instances have same hardware type, but based on the request type, some connections are able to serve the traffic in very quick time, but some are taking more time, right? So let us say overall we have 200 connections. 17 connections this instance is serving, 50 this is serving, 30 this is serving, and 20 this is serving. So based on least connection, irrespective of hardware size, whenever new request will land onto this load balancer, that will be forwarded directly to this EC2 machine, because this has the least connection. The number of concurrent connection which this instance is serving are very low. So based on this particular like software configuration or like mechanism which is implemented on this load balancer, so based on least connection, like instance serving less number of connection will have to accept new request coming from internet.
Looking
Yeah.
followed, like this least connection is like these are hardware load balancers or
Come again.
no, like we are setting up this least connection and weighted load balancing, right? So these are all like the mechanism that we can assign with the load balancer, or these are comes under software load balancing as we have to implement it.
Okay, so basically these particular can be implemented along with your Nginx as a load balancer, weighted disconnection, all the like load balancing algorithms are supported by Nginx, which is known as your software load balancer, as well as your elastic load balancer, or which comes under application segment. We can define these sort of mechanism there.
Okay, but physical load balancer does support only round robin, right?
No, like it can also support weighted and disconnection. That depends on the like type of physical load balancer which you are using. So even F5 supports all these features.
Which support? Sorry, come again on that.
F5.
Okay.
That is a
So,
physical load balancer.
Yeah. So on AWS, only round robin.
No, not only round robin. Even weighted is supported. Even least connection is supported. And one more thing, which is on the top of these, like these three, which is known as sticky session.
Yeah, sticky. That is fine.
So many people, I don't know why, but they are interested in knowing like what is the use case of sticky session. So guys, sticky session is not a like load balancing algorithm, but yes, we can enable sticky session along with either of the protocol, whether that is round robin, that is weighted, that is like least connection. So if we have enabled any sort of these connections, or these algorithm we have enabled, on the top of this, we can set up one more additional configuration item, which is known as sticky session. Now, what does that mean? Let us say there are two users, right? These are two users coming from internet. So if this user's request was served, first request was served from this instance, if this user is returning maybe within 10 seconds, maybe within 2 minutes or like that. So this particular span could be from 2 seconds to 7 days. The particular span for returning of this user could be from 2 seconds to 7 days. Like if this user is returning within 2 seconds or returning within 7 days, then the request of this user will be served from this instance only, irrespective of waited or least connection or round robin. That does not make a difference here. If sticky session is enabled, or we have defined a time frame that if a user is returning within this time frame, the request will be served from the same EC2 machine. Right, guys? Now, this user is also returning, and let us say this user returned after 3 days. And the particular time span which we defined, that was for 2 days. So that will be treated based on like weighted, least connection, or round robin mechanism. Once a connection is served, once a connection is established with either of the instance, like this 1, 2, 3, 4, whatever. So once the connection is established for, then in that case, this load balancer will keep on waiting for next 48 hours or 72 hours, whatever the time we are going to define. So if a user is returning within that amount, within that period of time, so request will be served from the same instance. Now, an interviewer can caught you, or that an interviewer may want to know something additional information here, such as, okay, we have enabled sticky session here. The user is returning user for us, and this instance was used to serve the request last time. Right, guys? But due to some reason, this instance is no more. One new instance is created out of that AMI, and now that instance is available here. Now what would happen? Yes, guys. Did you get my question?
Yes,
Sir, yes, sir.
Then answer, please.
As per this algorithm, round robin, weighted, or whichever that's used in that infra, follow those algorithm and serve the request.
But what about sticky session?
There is a backup from a dead EC2 instance, which is allocated to new EC2.
Okay. Any other thing?
Sir, am I audible?
Yes, yes, you are. You are.
Oh, okay, sir.
Anyone else would like to add anything here? There are so many guys, but only 2 or 3 are speaking. I don't know why.
Sir,
Yeah, please.
yeah, based on the load balancing configuration and load balancing algorithm, it would route the traffic to a new instance or the existing instances. And the sticky session would be continue further with that instance.
Okay. Would you like to add anything else here?
He is go for sticky session is not available, then he follows the regular algorithm, whatever this implemented.
Okay. Now let me explain it to you guys. See what happens. How does sticky session work? There are 2 things which are mandatory in order to enable sticky session. First of all, cookies. Now, what are these cookies? Not that one which we usually prefer to eat, but the cookies of application. There are 2 types of cookies enabled based on application and based on load balancer. So now load balancer is capable enough to understand the information which is coming from the client side. Client is this actor, right? Like what laptop or desktop this user is using, what version of browser it is using, what is the type of browser it is using, right? Like what is MAC address and other information of that user. This load balancer is capable enough to like catch. Moreover, this instance which is being served, so it will hold the information of MAC address, IP address, and other information of this instance also will be captured by this load balancer, because load balancer is the place or is the like component which is being responsible to enable sticky session. Right, guys?
Okay. Yeah.
So if either of, let us say if user goes off or the machine goes off, in that case, that session will be terminated. That session will not be treated as existing one. That will be treated as new request. In that case, sticky session is only enabled once the particular requirement meets. Like this load balancer has information about the user, like cookies of that particular browser and information of the server. If both informations are available on this load balancer, only in that case, sticky session will be implemented, otherwise not. If any of the component, maybe this EC2 machine or maybe this user, if any of these goes off, then sticky session will be considered terminated. And once it is considered terminated, then based on the like algorithm which is enabled on this load balancer, request will be forwarded to these instances based on like this primary algorithm. Clear with that?
Yes,
sir.
Great. Sounds good. Now, guys, one more thing I would like to add, although that is not that important, but yes, I would like to add that thing here. One more type of algorithm is here that is known as transparent. Transparent means, for example, we have only one EC2 machine here, but that machine is behind load balancer. Although it does not make a sense to keep one instance behind a load balancer, but yes, if there is a scenario wherein we need to have only one instance to serve our application request, then it is considered to be as transparent algorithm. We have one load balancer, we have one instance, whether it is working or not, it is up or not. So each and every request will be forwarded to this load balancer, this instance only, and that is considered to be transparent algorithm. One load balancer, one EC2 machine. That is it, nothing else. Okay. Now, guys, one more thing, and which is very important, which I'm going to discuss with you guys right away. Okay. So what are the use cases where we need to enable sticky session? Yes, guys.
Bank transaction.
Yeah. Please go ahead.
Bank transaction, sir.
So do we need to enable sticky session or not?
Yeah, need to enable.
Okay, what if we do not enable, then what would happen? Will all the transactions take place or not? Yes, Deepak.
It will take place, but like I'm not sure exactly, sir.
Okay, good.
Say, for example, if in particular a testing is in phase, so where people are trying to do the same journey multiple times, so in order to serve that request, maybe sticky session will be enabled. I mean, will be benefit for them to do that. Or else this works on the campaign as well. So
to avoid DDoS attack.
Okay. Let's not talk about DDoS attack, otherwise you guys will be in hot soup. I'll start asking about DDoS attack as well. So let us not discuss which is not in scope right now. Okay, not a problem. So guys, let me tell you two things here: stateful versus stateless application. Just type in these two words into your browser and start studying about it. If you understand what is stateful connection or stateful application versus stateless connection or stateless application, then you shall be able to answer the question. Like, in which scenario do we need to enable sticky session or where we need not, right? So that is it. That is a keyword for you. Fine, guys. So now we understand that this is a load balancer, which is application load balancer, and the scheme here is internet facing load balancer. It is right. Okay. Now we have web servers which are running here behind this application load balancer. Now, guys, once again we are going to have some other load balancers here, which are going to be okay. We are going to have here application server. Right, guys? We are going to have here other target groups where our application servers will be working. Now these web servers will forward traffic to this load balancer. Because if we have more than one instance, then definitely, guys, there will be requirement to have load balancer. Now, what type of this load balancer is going to be? First of all, this will be network load balancer. This is going to be, okay, spelling is mistake here. I'm poor with English. Okay, this is going to be network load balancer. Moreover, it is going to be internal. Like this load balancer is not supposed to accept traffic from internet. Right, guys? This network load balancer will be internal load balancer. Moreover, this is not supposed to accept traffic from internet. Right, guys?
Yes, sir.
And why is that so? Because it is only supposed to accept traffic from these servers. These are going to forward request to target groups. Right, guys? So let us say the application is working on any random port. Let us say 9234, for example. So what is going to happen whenever request from this particular server will be forwarded to this load balancer? So irrespective of whether that is for HTTP, that is for DNS, that is for MySQL, that is for Oracle. So any sort of request, this load balancer will accept request from here, and based on the port number, it will forward request here. Now, guys, usually people talk about that this is layer 4 load balancer, this is layer 7 load balancer. So, guys, application load balancer is layer 7 load balancer, and network load balancer is layer 4 load balancer. So, guys, do we have an idea like what is the difference between layer 4 and layer 7?
Layer 7 is application layer and layer 4 is
network layer. That is why it is known as network load balancer.
Application layer supports, sir, 443 and 80, HTTP and HTTPS.
Which load balancer you are talking about?
Sir, application layer 7.
So even any load, any port number it can support.
Sir, network, but networks, sir, support TCP and UDP.
It support TLS as well.
Yeah.
Go ahead. Okay, fine, leave it. We will discuss in detail when we will be discussing about this particular component, which is known as load balancer, right? Okay. So, guys, now what do we have? We have like web servers. The same component, like auto scaling group, will be configured for this particular target group as well, right?
Right, sir.
Like if number of instances are required to be increased or reduced, then definitely we can talk about this one. Right, guys?
yes, sir.
Okay. So now next thing here is we will have a particular database. Now that database will be, let us say, that is running with MySQL. Right. So let us say we have one master, and let us say we have two slaves. This is a slave, and this is also slave. Right, guys? Now, what do we want? So we want to do load balancing for this as well. What does that mean? We want to do load balancing. We want like if any read request is coming, that should be forwarded here. If any read request is coming, that should be forwarded here. If it is write request, that should be forwarded directly to this master instance. Now, how we can achieve this? Yes, guys, how we can achieve this?
Using roles in load balancer.
Target group, sir.
Okay, target groups.
We
But
can
let us
create-
say if load balancer like auto scaling group identified that this master server is running with high load and it has breached the threshold, right? Auto scaling group will terminate your master database. Then what will you do? Did you get my point? If you put MySQL master and slave inside a target group under an auto scaling group, if due to any unforeseen reason there is high load found on your master database, auto scaling group will go and terminate your master instance, your master database. Then what would happen, guys? So your answer, guys, you guys are not being interactive. I don't know why. Vikas Tripathi, what is your call on this?
Sir, actually, I'm learning these things very first time. So yeah.
That is fine. You are learning, but at least any idea about it. Not a problem. Then let me explain. You are learning and I'm teaching. Every day there is some new learning. Okay, not a problem, guys. So guys, there is a component known as proxy SQL. This is an open source tool. Just like MySQL, you can install it on any instance. So guys, if we have proxy SQL, then we are going to replicate it into 2 instances. Why is that so, guys? Because still we want to have some sort of failover. For example, if this proxy SQL goes down, then this will be up and running. If this is going to go down, then this will be up and running, right? Like if one goes down, another will be up and running. Okay. Now, these instances are supposed to be managed by an auto scaling group, right? Moreover, there will be another load balancer which will be placed here. Like now, all the application servers are going to request in order to go to database to this instance. All the application servers will hit this network load balancer. This network load balancer will forward request here to these like proxy SQL servers, right, guys? Now these proxy SQL servers are going to be responsible to understand the type of query, such as if it is select query, it will be forwarded here and to this particular node, right? If it is, let us say, any query except select is the only read query, right? If we talk about like other queries rather than select, it could be delete, insert, alter, update, or maybe you want to build some sort of indexes on any table. So every other type of query will be forwarded onto this particular server, which is MySQL master. Whatever changes are found here, obviously we are very well aware of it, that whatever changes are made onto master database, these are replicated onto slave automatically. Are we clear with this thing, guys?
Yes, sir.
Any questions so far? And guys, one more thing. See, right, so far we have 3 load balancers. This load balancer is public facing. This is application load balancer. We have network load balancer. This is internal. Once again, we have another load balancer, which is internal and which is being used for proxy SQL. Okay. Now there could be a question that why we have put these proxy SQLs inside auto scaling group, wherein these servers, which are actual database servers, these are not part of it. So guys, these proxy SQL servers are going to be responsible to identify the type of query, whether it is read or write query, it is delete, update, alter, insert, well, like what type of query it is. If it is read, it will be forwarded here. If it is anything else rather than read, it will be forwarded here. Now these both servers are going to be replica of one another, and we will create one image of this particular machine, and we will hand over that image to this autoscaling group. We have 3 autoscaling group guys now. One for proxy SQL, one for application servers, and we have one for
Web server.
servers, right? Okay. Now guys, if you think of, okay, any question so far?
Sir, for app server, application server also, we need to create one AMI and we need to add into autoscaling group.
Yes, one AMI we need to create for application server. We will add the, we will attach that here.
And one more thing, sir, you used one load balance.
Go ahead.
Autoscaling group to load balancer to proxy SQL.
Yes.
Which load balancer we need to use there?
Network.
Okay, sir. Every internal thing we need to use a network only, or we can use application load balancer?
We can use application load balancer as well. His scheme is going to be like internal load balancer only. That is not supposed to be like public load balancer.
Okay.
So this is how our infrastructure is going to look like. Now, let us say we are working with the e-com platform, right? We need to enable like indexing, or maybe we need to enable listing of our product. So what we can do here is we can use Elasticsearch here. Because Elasticsearch uses Apache Lucene. Apache Lucene is really fast indexing mechanism, right? So Elasticsearch, we can integrate with this. Let us say if some user is trying to list the number of products which we have on our platform, then we can use your Elasticsearch, right, guys? Not only this, let us say if you want to verify the particular detail which provided by any user, whether these are authenticated or not, so we can use your Redis. So guys, these components will be decided by your developers only, right? So that will be, that is going to be different use case.
Hey John, can you explain that again? The Elasticsearch and the Redis?
Your voice is low, buddy. I'm sorry to say.
John, can you hear me?
If you are talking to me, then your voice is really low.
Sir, can you explain again for Elasticsearch?
Yes, for sure. Okay, wait, let me go on to any product. Okay, here. So guys, if you see, there are a couple of images available, right?
Yeah.
And if you go down, so there will be a certain limit. Like after that, you will have to jump onto a new page, right? So for
Yes, sir.
example, if I go here next, then it will load some further, some new images. Do you see like how fast is it? If I have
Yes.
to jump onto page number 10, then it will not take even a single second to load all the images, right? And how it is happening this much faster? Because these products are not being fetched from any database, but these products are loaded here into this Elasticsearch. Right, guys? So this is a complete pipeline. And how does that work, guys? Like that pipeline, if I have to tell you, so I can explain that to you as well, but you need to understand like how does e-commerce platform work in that case. Is there anyone who has ever got a chance to work with e-commerce platform?
No, sir.
Okay, then let me tell you. Okay, so guys, let us say this is Elasticsearch. So this particular pair of shoes goes out of stock. How Flipkart is going to notify customer that this is currently not available?
They will hide that post.
But still they are showing here, but the availability section is showing unavailable. This is showing
Okay.
available. They would not hide it.
No, in backend they can mention like currently unavailable from admin side.
Okay, wait. Sometimes you might have seen like it is usually written that only 2 are available in stock.
Yeah.
5 are available in stock. And
Yes,
if you refresh once again, that it is out of stock. So how does that happen in real time? Any idea, guys? Anyone? This is a question to open forum. So whosoever has any idea about it, we can discuss. And a wrong answer is better than no answer.
So there is one in backend they can log into admin page and they can edit that thing.
Okay, they can log in and let us say they have updated that only 10 pair of the shoes are available, right? So what will you do in that particular case? Let us say one person bought 9 pair of shoes at once. How will you get to know that only one is remaining? That is not your job. Because if you refresh, let us say the particular person is trying to purchase 11 pair of shoes. So you cannot put a limitation that a person cannot purchase more than 10.
Yes.
So how would that happen? Let us go through that. So guys, there is a particular component which is known as WMS. Have you heard this term before? This is known as warehouse management system. So this is a particular tool, or this is a particular application or interface which is created for backend users. Backend users means the particular administrators who are responsible to update the product, the category, the prices, the discount, and every information about the particular product is being entered or is being uploaded by these particular administrators only, right? So this administrator has a different URL. For example, wms.flipkart.com, right? Only limited users and who are authenticated and who are authorized to access this URL will be able to log into this, because these are administrators. Now, whenever they will update or they will add any product, so that entry will directly go into this master database, right? Okay, let us say the particular product owner identified that we are running out of stock. So that information will be updated here. And that information, once that product is out of stock, so that information will be replicated to this particular category immediately. Now, this Elasticsearch has information that yes, we have product and anyone can come and can purchase, because this Elasticsearch is directly not integrated with this MySQL slave. Right, guys? So now what is going to happen? There will be a particular new tool, which is known as Maxwell. So there is a particular software, this particular will be used. Now, this particular software will keep on reading the binary log of this database, right? Or let us say if you are working with Oracle, you can talk about Golden Gate. If you are working with Oracle, you can talk about Golden Gate. If you are working with MySQL, then you can use open source Maxwell. Right, so these are two different softwares. You can use either of. So these are two different components here. So they are going to read the binary log of MySQL. Now, there will be another software which will be used here. That is known as Kafka. Now, guys, what is Kafka? Anyone have ever used this particular software, Kafka?
For messaging.
Messaging of what? Like WhatsApp?
No, sir. Like if any thing change, it will message to Elasticsearch.
It's also like a database.
Okay, so let me tell you guys, there are two components. Then both the products are of Apache only, Apache Foundation. It could be Kafka or it could be Pulsar. Right, guys? So these are a streamlined messaging processor. The messages or the particular like transaction which are taking place in real time. So these are handled by Apache Pulsar, Apache Kafka. Now, based on these events, whatever are read by Maxwell from MySQL bin log, these messages or these changes will be pushed by Maxwell or Golden Gate to Kafka, right? Now there will be one another application, which is a customized application. Reason being, like what you are going to do with these messages. Let us say you can send email to an end user. You can call a customer. Maybe you can notify the application in order to like do what. So there will be like CDC, consumer application. There will be a consumer application. That consumer application will read the data from Kafka topics and will update to Elasticsearch. Now this is known as a complete pipeline. This is now a complete pipeline, guys. And what does it mean? What does it mean? It is a complete pipeline. So guys, just see in real time, if some administrator is going to update anything into database, so that will be replicated immediately onto slaves, right, guys? As soon as slaves will get updated, so that information from the binary log of Oracle or from MySQL, that will be read by Golden Gate or Maxwell. As soon as this information is read by this, it will send a message to like Kafka to Pulsar. This will send a notification to like consumer application. Now consumer application knows very well that how to like manipulate this information and how to update that information to Elasticsearch in real time. So as and when the Elasticsearch is updated with new information, so as soon as the user is going to browse this and to refresh this particular screen, so the user will get the latest update of that particular product. So guys, this is how it works in real time. So guys, how does it look? Now, will you be able to explain the infrastructure in a proper way? Yes, guys. Still no voice.
Yes, sir, you can try once.
Will you will you be able to explain or not? Otherwise, like it seems that I have spoken for more than 1 hour and 10 minutes now, and see the responses. Okay, not a problem. One more thing. So guys, if you want to enable caching, then caching means like if you would like to implement CDN. So where you are going to implement that? Let us say you would like to enable CDN. So let us not give it up like any specific name. Let us call it CDN itself. So guys, CDN will be implemented on the top of it. Your request will be served in that way. First of all, CDN means like if you are working with AWS, you can give it a name like Cloudflare, like CloudFront. If you are using any open source, you can go with Akamai, or you can go with Cloudflare. Maybe there are some other vendors are also available in market, which you can use in order to configure your CDN. CDN stands for Content Delivery Network. Right, guys? Moreover, whether it is Akamai, it is Cloudflare, it is CloudFront, so you can integrate one more component like right away right here, and which is known as your WAF. web application firewall. So this will help you to like prevent your website from DDoS attack, from SQL injection, from like CXX, like cross-site scripting. So that sort of attacks you can prevent with the help of WAF and Shield. Like these both are components which are provided from the side of AWS. So you can integrate WAF and Shield along with CDN, or if you are not using CDN, you can directly integrate WAF and Shield with your application load balancer. Right, guys?
Right.
Now, if we have to talk about security, then this particular application load balancer will allow traffic to be accepted only on port number 80 and port number 443 from internet. No other port will be opened here. Now this target groups. So first of all, this will allow, if I talk about this particular target group, so this will allow to accept traffic on port number 8433 from this application load balancer. But obviously, guys, as we know, like even we will have to log into this in order to do management, in order to do maintenance activity, to do deployment, and to check the logs and other things. So in that case, we will have to whitelist port number 22 as well here. So these application servers will allow to accept traffic on port 22 as well. But first of all, we will have to create a jump server. We will discuss in detail like what is use case of jump server and all. So we will log in to this particular application from jump server or from any other instance as well. We can jump into this. So when we will be discussing about VPC in detail, at that moment, we will try to understand like why do we open port number 22? What are the different routing table we are going to have? What different subnet do we need to create? So that sort of things we are going to discuss in really detail, guys, in coming sessions. So guys, now this is the time to like ask for the feedback. Yes, guys, any feedback for the session?
So
it's very nice. Like it's really help us to understand this proper architecture in real time scenario.
So guys, when people call like, will you provide the like any real-time project? So guys, is there like, can there be any better real-time project than this?
No, sir.
And going forward, we will try to implement this because right now we are going to expand this particular page only like where do we integrate Jenkins, how we are going to use GitHub here, how we are going to enable Dockerization, like Ansible, where we are going to use MySQL, what sort of a web server we are using here. So like only this diagram will be expanded for next couple of days now.
Okay, sir.
Any other one who would like to share any feedback for the session?
Thank you for the session. It was really informative and very insightful. Thank you.
Thank you for your kind words, ma'am. Yes. Any other one?
It would be better if you count the number of instances you're using in each target group in a real time.
Pardon, come again.
If it is a real-time project, it would be even better if you, for an analogy, if you say sample number of instances in each target group.
Okay. So same thing, I'm telling that right now the particular diagram is yet not completed. So we are going to check like on what basis, let us say if I define that we have 8 instances. So we are going to discuss about this thing as well. Like why do we have 8 instances within this application stack? Why do we have 16 servers here? Why do we have like 2 masters and 4 slaves? So on what basis we are going to have? So be not to worry about, I'm going to explain this in really detail within coming sessions.
Sir, what are the main tools in AWS we need to focus for DevOps?
So if you are looking for AWS DevOps, so like it will require your couple of tools like such as code deploy, code pipeline, code build, code commit, X-ray, pipeline, that sort of components you need to focus on. For AWS DevOps especially.
Or only for DevOps, sir?
If you are talking about DevOps, then open source DevOps would require like Git, Jenkins, Docker, Ansible, your MySQL, Prometheus, Apache. ELK, this sort of component you should be focusing on. And this is not it, guys. When you will join any organization, so there will be some customized tool which will be used there, right? So you will have to keep learning always. As long as you are a DevOps, you will have to keep on learning. So guys, I'm going to stop recording of the session and we'll share. This is the final demo session for you guys. Now tomorrow onwards, only registered candidates will be allowed to attend this. Thank you so very much.